In this video, I'm going to explain about typecasting, one of the unique feature in the C programming language. See, what is mean typecasting? We know type, that means different data types are there. So there are 5 basic data types are what? Int, char, float, void, double. So these are the 5 types. Sometimes we need to convert from one data type to another data type. Okay, that's what the casting, that means changing. So typecasting is nothing but the process of converting from one data type to another data type. So let us see that in C there are 2 types of typecasting. Okay, 2 types of typecasting. One is implicit, also called as internal typecasting, and another one is explicit, also called as external typecasting. Okay, so typecasting is of 2 types: implicit typecasting, also called as internal typecasting, and explicit typecasting, which is also called as external typecasting. Okay, now let us see implicit typecasting. So now I'll write one program. Let us take, say, some program void main. So what I will do, I will declare two variables of integer. Let us take int a is equal to some 10, and I am declaring one more variable int only b. Let us take 4. Okay, so I declare these 2 variables and initialize the values here itself. So now what I will do, I will declare one more variable called float, and I will say res, start from result. Okay, so next I will clear the screen using CLRCR, and then now what I will do, result is equal to a divided by b, and this is the arithmetic division operator which gives us the quotient. Now I am printing the result. Okay, so for that, printf, okay, result is equal to what? I am printing this value. So this is what I declared as floating point. So use percentage %f /n. So then the variable name is res. Okay, so then as usual, always at the end get ch. Okay, so this is my program. Now what we are expecting, so when I run this program, I am expecting what? So when I divide a value is 10 and divide by 4. So when I divided 10, so 4 2s are 8. Okay, so I should get remainder 2. So now here I am doing the division operation on 2 integer values. 10 is an integer value, 4 is an integer value. See, our compiler always will do operation only when both the operands are the same type. Okay, so that means whatever the operation, not only division operation. Suppose if I say a plus b, or a minus b, or whatever, a percentage b, or a greater than b, whatever, whichever the operation. So whenever our compiler is doing any operation, both the operands should be of the same data type. Okay, so here is both are the same data type. So, okay, if it is different data types, what it will do, it will automatically converts lower data type to higher data type. Okay, I will repeat, compiler will automatically, that means internally, converts lower data type into higher data type without the knowledge of what? The user or the programmer. That means we don't know what is happening inside the processor. Okay, the compiler automatically converts lower data type to higher data type. Which are the lowest data type? So we know that char. Char is the lowest data type because it requires only 1 byte. Okay, so next minimum is what? Int. So okay, int is the next lowest. So next lowest is float, and the highest data type is what? Double. Okay, so highest data type is double, lowest data type is char. So now I am using 2 variables as an integer, and I am doing division on these 2 integer variable. Yes, fine. But when I do this one, both are same data type, So 10 divided by 4, so average is 2. So that 2, when I am assigning the result of the 2 to the result, so the 2 is integer value and res is the floating point value. Now automatically it will convert the result 2 into 2.00. Because 2 is integer, it will convert 2 into 2.00 and assign it to res, and that 2.000 will get printed. But actually what happens, when I divided 10 divided by 4, actually I am expecting 10 divided by 4, 2.5. I'm not getting 2.5, I'm getting only 2. That means here I'm going to lose the data by 0.5. That means instead of 2.5, I'm getting only 2. So this is the problem. Okay, so Let us see the same thing in the programming. See, this is the program, whatever I written on the board, same thing I typed already. Now I will execute this. See, now what I'm getting result is equal to 2.00, but I'm expecting what? 2.5. Why? Because when I divide 10 divided by 4, A value 10, B value 4, 10 by 4, actually I'm expecting 2.5, but I'm getting 2. So what to do that for that? So now that means I need to what? Make it anyone as the floating point. Okay? So that anyone, either A or B, I need to make it float. Now what the changes I will do, instead of declaring B as a float integer, now I will declare B also as floating point. B is equal to say 4.0 I will say. Okay, I declared B as a floating point. Now I did the same thing, everything is same. Now what happens? See A is what? Integer. So that is A by B is nothing but 10 divided by 4.0. Now when I'm doing a division operation on two operands, one is integer, another one is floating point. Now what our compiler will do, our compiler automatically converts lower data type to higher data type. This is integer. Okay, see, this is integer and this is floating point. Among integer and floating point, which is a lower data type, integer is a lower data type. Now this integer is converted to higher data type by the compiler automatically. So now what happens? Same thing is written as, now integer is converted means 10.0, it will convert into floating point, higher data type. Now 4.0. Now both are what? Now both are of same data type, floating point. Now it will divide. Now it makes 2.5. That will be assigned to Argus. Now we'll get 2.5. Okay. So let us see. So just I will change this value. Okay. I'm making only A as integer, and I'm declaring B as a floating point. I'm making this as 4.0. That's it. Okay. So then everything is same. Now I will check for the errors. No errors. Okay. So then I run this. See, now I'm getting what? Just a minute. See, I changed B as a floating point, same as in 4 to the B, and I declared B as a floating point, and then same thing also to A by B, and I printed the result value. Same thing, I didn't do any changes. So instead of declaring B as integer, I declared B as a floating point. That's it. Same value I given. Okay. So now I will run this program. I'll check for the errors. No errors. So then again I compiled, executed. See, I'm getting 2.5000. Okay. Now this is how internal typecasting works. See here, I'm instead of getting extra 5 zeros, by default always we will get 6 digits after decimal point. After decimal, see 1, 2, 3, 4, 5, 6. All by default you will get 6 digits after decimal point. So but we can print how many number of digits we want after decimal point. That many number of digits we can print. So that I will show you now. So just in here, whenever you're printing floating point, so after percent, you say 0.2. If I say 0.2f, that means after decimal digit, so then you print what? Only 2 digits. That's what the meaning. So percentage floating point per dot 0.2, that means after decimal point, print 2 digit. Okay. Now I will check for the errors once again. No errors. So I run this. See, now instead of 2.500, now I'm getting 2.50. Like that, we can print how many number of digits we want. That many digits we can print after the decimal point. Okay. Same thing. If I did changes what? So only one. So I will get only what? Only one digit after decimal point. Okay. See, here I'm getting now 2.15 only. Okay. So this is how we can print however we want, like that we can print. Now the summary is implicit conversion, also called as implicit typecasting, also called as internal typecasting, done by compiler automatically without the knowledge of the programmer. So whenever compiler is doing any operation, both the operands should be of the same type. Whenever there is a different type of data types are there, our compiler automatically converts lower data type to a higher data type. Okay, that's it. But it never converts higher data type to lower data type because it will lose the data. So, but sometimes we need to convert the higher data type to lower data type. So at that time, it is not possible to use implicit conversion. We need to do it externally. That means we user or programmer has to do externally. Hence, we go for explicit typecasting, which is also called as external typecasting. So now we are discussing explicit conversion. So I will take the same example now. See, I declared again the two variables a and b, both are declared as an integer. Again, same 10 and 4 are given to a and b. I declare one variable res, and the res is equal to a by b. So here it will do what? A and b both are what? Same data type. So it will do what? Integer, both are integer. It will do operation. I will get 2, and when I am assigning the 2 to result, 2 is an integer, res is floating point, it automatically converts what? The floating point, integer into floating point, I'll get 2.000. But actual value of 10 divided by 4 is 2.5. Okay, but I'm getting 2.00, I will lose the data up by 0.5. 0.5 data I'm going to lose. Okay, that I don't want to lose it. Okay, again I will show by running the. See, I have typed the same program. So now I will run this program. See what I'm getting? I'm getting 2.00. So it will what is the problem? It automatically converts whatever the result 2.5 into floating point 2.00 into floating point. That's why I'm getting only 2.00. But I don't want to make it. So what I will do? So I will convert any one of the variable as an integer. See, just I converted any one of the integer variable as a float. Here what I did, so that I converted, a is an integer variable that I converted into floating point, and now I will run this program. See, and now I'm getting 2.500. This is as expected I'm getting. See, now what I will do, so just actually what I'm doing, a divided by b, both are integer variable. So this one of the variable, any one of the integer variable, I will convert it into float. So meaning of this statement is, now I converted a externally, that is forcefully, we converted a into float. So now what happens? So this will be written as this line. So a will be converted as float. So it becomes what? 10.0. 10.00 actually by default 60 divided by this b are not converted. B is as usual 4 only. But now compiler won't do operation on this because this is floating point data type and this is what? Integer. Now what? Now again our compiler automatically will do implicit conversion. It will convert this into 10. Now both are floating point. Now we will do operation. The result is what? This 2.5, and that will be assigned to what? RES. Now RES is also floating point. Now this is also floating point, and this value will be assigned to RES. So this is what I showed in the program. Okay. So this is what explicit conversion. So now in general syntax, whichever the variable we want to convert, assume this is one variable. This variable I want to convert. So whichever the variable you want to convert, that before that variable, you just write that what type of data type you want to convert it. Okay, suppose this is variable, I want to convert it into integer, right? Within the bracket integer. That means this variable is converted into integer. Suppose this variable you want to convert it into floating point. In this bracket you write floating point. So like this. So like this, within the parenthesis, which variable you want to convert into what type of data, that type you write. So okay, this is the general syntax of explicit conversion. Okay, hope you people understood the typecasting. There are two types of typecasting: implicit and explicit. Implicit typecasting will be done by compiler automatically, so without the knowledge of the programmer. So always in implicit conversion, compiler converts lower data type to higher data type. Okay, reverse is not possible. Okay, but sometimes we need to convert from any data type to another data type. For that, we go for explicit conversion, and this is the some standard example. Hope you people understood. If you have any question, please write it in the comments. Thank you. Thanks for watching.